Imagine 300 mid-sized cars floating above your head. That's how much this cloud weighs. So, how the heck is it floating? So first things first, how did this cumulus cloud get up here? Well, it wouldn't be up there without the sun. Solar radiation heats air and water vapor near the ground. That air and water vapor then start to rise because they're less dense than the air in our atmosphere, which we know sounds weird and we promise to get back to in a second. So as water vapor rises, it cools. As it cools, it condenses back into tiny, tiny droplets of water or ice. These droplets are spread throughout the cloud and scatter sunlight, which is what creates that whitish sheen that we on Earth interpret as a cloud. Although each individual droplet doesn't weigh much because it's so minuscule, together they add up, a lot. Meteorologists estimate that cumulus clouds have a density of about 0.5 grams per 1,000 liters. The average cumulus cloud is about 2 kilometers across, 2.5 kilometers deep, and around 200 meters tall. That turns out to be a volume of about 1 trillion liters, giving us 500 million grams of water, which is about 1.1 million pounds, the weight of those 300 mid-sized cars. So, how the heck is it floating? Let's first quickly turn to the ideal gas law, which says that in a given volume of any gas, at a given temperature and pressure, there are the same number of gas molecules. So 2 liters of dry air, a mixture of mostly nitrogen and oxygen, without any water in it, has exactly the same number of molecules as 2 liters of water vapor. The molecular weight of dry air is around 29. Water has a molecular weight of 18, a lot less. Since density is weight divided by volume, the gas inside this 2-liter bottle is less dense than the gas in this one. So that's why humid air is less dense than dry air, and explains, along with solar heating, why air and water vapor rises. But once it's up in our atmosphere, it will expand, cool, and change into those tiny water droplets we mentioned earlier. And you'd think that they'd fall out of the sky, but they don't, and here's why. When water vapor condenses into those tiny droplets, heat is released. That heat causes the air in the cloud to expand, making it less dense compared to the surrounding air, and so it rises. That column of rising air is called a thermal. And thermals are really the engine that drives cumulus cloud formation. And fun side note, thermals aren't just useful for creating clouds and keeping them floating above us. They're also used by hang gliders and balloonists to stay lofted. So although by eye it looks like a fluffy cloud isn't doing much, that's actually not true. It's experiencing a constant cycling, updraft and condensation, downdraft and evaporation, updraft and condensation, and so on. What that means is that all those water molecules that make up the cloud are being cycled through gas, liquid, gas, liquid, gas, liquid, constantly. And you can throw ice crystals into that mix if the cloud grows vertically enough to tap into that really cold air in our upper troposphere. And that's how a 1,000,000-pound cloud floats. And it'll eventually come down on us, just very, very slowly. PBS Digital Studios wants to hear from you. We do a survey every year that asks about what you're into, your favorite PBS shows, and things you'd like to see more of from PBS Digital Studios. You even get to vote on potential new shows. All of this helps us make more of the stuff you want to see. The survey only takes about 10 minutes, and you might even win a sweet t-shirt. Links in the description. Thanks.